Okay, guys, we're doing warm-up 22. Okay, so alkali metals, how many valence electrons? Oh, that sounds weird. One valence electron. And how will we get a full shell for these guys? Gain one. Gain one? Lose one. Okay, alkaline earth? 2 valence. What do they want to do? Lose 2. Okay, chalcogens. Okay, so how will you get to a full shell of 8? Gain 2. And then halogens. 7, so they need to gain 1 or add 1, yeah. Okay, so now going through these, so if you remember from yesterday we talked about elements, atoms, molecules, and compounds. So what do you think this thing is? It's a compound, because there's different types of atoms. Also, because it's more than one atom, we could also call it a molecule. What about this? Yeah, it's an element. Like if you can find gold, AU, you can find it on the periodic table, so it's an element. But how many atoms are there? 1. So we can also call it, because it's just one thing, it's an atom. Remember, a molecule has to be 2 or more things, and a compound is 2 or more things that are different. The compounds, they have to be different things. So oxygen, can you find oxygen on the periodic table? Yes. Okay, so it's an element first, because we found it on the periodic table. And then it's also a molecule because there's more than one oxygen, so it's also a molecule. Now, what about NaCl? It's a compound. And because there's more than one thing, we'll call it a molecule for now. When you get further on in chemistry, the types of bonds will dictate whether it's a compound or molecule. But for right now, we're just going to say if it's 2 things, it's a molecule. If they're different, it's a compound as well. Okay? All right. So yesterday, we finished these, or we got through some of these notes. Well, let's finish out these off. Yeah, so actually, I'm just going to do this. I'm going to go right down to where we were. We should be here. Right? Okay, so we talked about atoms, elements, molecules, compounds yesterday, and that's what we're just kind of doing in the warm-up. So particles. In chemistry, we have fancy words for stuff. So when we talk about things, like in real world, we talk about things all the time. This and stuff, and this is things, and whatever. But in chemistry, the things we're talking about are super small. So we call those particles. Things are called particles in chemistry. Turn that down a bit. And everything in the universe is made of these tiny particles, and we call those atoms. Right? Nothing crazy there. And if we put atoms together, 2 or more atoms will make a molecule. If they're different, we can call it a compound. So if you were to imagine, like, let's talk about water. Water is made of small particles. Those particles are molecules, H2Os. And you would have H2Os that are really close together, H2Os that are a little further apart, and H2Os that are even further apart. That would be true for any solid, liquid, or gas. So it kind of looks like that. It depends on what we're talking about, though. If our particles are just gold, then we could talk about atoms of gold, right? So it depends whether things are molecules or atoms. A particle is just something. So we talked a bit yesterday about pure substances and mixtures. So if something's pure, it's just that one thing, right? So if you have more than one thing mixed together, though, that's what we call a mixture. So think about it like this. Can you have pure water? Yeah, it's just water molecules, right? Just H2Os, a cup of just H2Os. There's nothing else in it. Is our tap water pure? Is there stuff in our tap water other than water? Yeah, we add fluoride to it, chloride to it, right? So that's not pure. There's also minerals in there and stuff. If we want to filter it or boil it, distill it, we can get pure water, and we would have just water. That's a pure substance. If we want to talk about a mixture, it's the stuff in the water. So tap water would be a good example of a mixture. Pure water, distilled water would be an example of a pure substance. There's about 10 million things that are pure. And now it depends, it almost depends on what you're talking about if you want something to be pure or not. Like, Zach, you got a Pepsi there. Is that a pure Pepsi? Is it just Pepsi in there? Okay, so that's just Pepsi, right? But if I mix some Sprite in there, would it be pure Pepsi anymore? No. So, but is Pepsi itself a pure substance? Well, it's made of a bunch of other things. It's also a mixture. So it depends on kind of how we're talking. Pure just means you have one type of thing. Now, there's tons of pure substances. Of those millions and millions of pure things, only about 112 are actually elements, right? Think of our periodic table. There's about 112 things on there. So the rest are always compounds or molecules. They're different atoms put together. So here's some pure substances. Diamond, right? You got pure water, right? We can have pure stuff. If you want to talk about like sand, you can have pure sand if it's just sand. Depends on what we're talking about. So here's an example. Baking soda. This is the chemical formula for baking soda. It's called sodium hydrogen carbonate or sodium bicarbonate. Yeah, it kind of does look like nacho. Nacho 3. Nacho? That's a good name for a dog. So if you take sodiums, hydrogens, carbons, and oxygens, you put them together a certain way, you get a molecule of baking soda, or the smallest unit of baking soda. Now, if you buy a box of Arm & Hammer baking soda, what are you buying? Just baking soda. It's pure baking soda. If you actually look on this box, it will say on there somewhere, they'll say 100% sodium bicarbonate, because it's just pure baking soda. So and I'm going to go on a rant here for a second. If you buy Arm & Hammer baking soda and it just says it's this chemical, would it matter what brand of baking soda you buy? If they say it's baking soda, shouldn't it be the same thing? Yeah. So if you go to the store and you have No Name baking soda or Arm & Hammer baking soda or any other brand of baking soda, it's all the same stuff because it's a chemical. It doesn't have a fancy logo. Same thing with like Advil and ibuprofen. They're exactly the same thing. One costs twice as much as the other. They're chemicals. It's the same chemical. You can only have so much of it, right? Like it is what it is. So baking soda is baking soda is baking soda. It's a chemical, and if it's pure baking soda, that's what it is. Arm & Hammer is no different than any other brand. So save the money. But anyways, can we have pure stuff? Yeah, this is pure baking soda. It's just baking soda. Even though it's made of different types of elements, it's the same molecules altogether. Pure oxygen. It's a molecule and an element, right? Because you can find oxygen on the periodic table. The oxygen in the air we breathe is O2. It's not just O, right? And yeah, actually most of the air we breathe is actually N2, which is nitrogen gas. But if you had just a container of just oxygen, O2s, you would have a bunch of little O2 molecules. So you have an element, you have just oxygen, and you have molecules because they're two oxygens together. Salt. We know salt is sodium chloride. So in this container, I have some sodium chloride molecules. I'll even put them on the camera. Let's see if we can get it up on, see if this works in the video. So I'm going to flip to this for a second. So there's a few sodium chlorides, right? And if I put them all together into a container, even though they're made of different elements, is that just one type of matter, though? Like there's sodiums and chlorines, but they together they make a molecule of sodium chloride. So if this is just salt in there, is that pure? Yeah, it's pure salt. There's nothing else in there. What if I put some water in there now? It's salt water, but it's a mixture of salt and water, right? So that's a mixture. Pure substance, you have one type of thing, and a mixture, you would have two or more types of things. Toothpaste. Toothpaste contains something called sodium fluoride. Sodium fluoride is a compound and a molecule. And I guess if we want to talk about, like I would say that toothpaste wouldn't be a pure substance, it would be a mixture of a bunch of different things. If we were just talking about toothpaste and there was nothing else in it, I guess we could say it's pure toothpaste, but toothpaste itself would be a mixture, kind of like your pop. It's really a mixture. Okay, move on. So here's some other things that you may come across. So vinegar. Vinegar is also known as acetic acid. In the notes here, like this. I always do all caps so you guys can see which words you have to fill in, right? I think usually whatever words are underlined are always all caps. So let's look at the compound there, like the formula of it. What's it made of? It is vinegar, but what is it made of? What are the different elements it makes it? Hydrogens? Carbons? Oxygens, right? So this is a group of atoms, different atoms. There's two things we could call this. We could call this a molecule or a compound, exactly. Compound. So that's what vinegar looks like. Drain cleaner. Ooh. Okay, drain cleaner is mostly sodium hydroxide. Some sort of hydroxide usually, but sodium hydroxide most commonly. What elements make up this? Oxygen and hydrogen, right? So that's what sodium hydroxide is. And it's also a molecule and a compound. Even though it's made of different types of elements, it's still a pure substance. It's one type of matter, just NaOHs. Chalk. We don't use chalk very much anymore, but if we did, it'd be calcium carbonate. What elements make up chalk? What do we got there? Calcium, carbon, and oxygen. So there's chalk. I got one more. Lime. Not lime like limes that you eat. Lime that we use to make like cement and stuff. And that's calcium oxide. No, cement will have some lime in it. Usually some calcium oxide. Right? It's a mixture of Portland and lime and whatever, I think, if I remember correctly. So on the next page, or below on your page, it just says, can you think of any pure substances you see every day? So let's talk about some pure things. Oh, did I miss one? Oh, I forgot ammonia. Sorry. There we go. Ammonia is NH3. Yeah, it's nitrogens and hydrogens. It's a molecule and a compound. Because ammonia is actually in Windex. So it's actually what evaporates quickly so it doesn't leave streaks. No, because remember, once you react, like once you have sodium in sodium hydroxide or sodium in salt or sodium in baking soda, the sodium has lost its electron, so it's not as reactive like it was before. Nope, not at that point. It's happy. Remember, it's lost its electron, it's happy. Baking soda will react with vinegar. right? Baking soda and water won't really do much, but baking soda and vinegar will, and that's got to do with acids and bases and stuff. The oobleck, yeah, water and cornstarch, yeah. I'm going to for my grade 11s for sure, so I'll show it to you guys too. Great. It's pretty cool stuff. There's lots of videos of people walking across it and stuff like that. And you're just mixing cornstarch and water just for fun? Why not? Okay, so let's talk about some things that you see in your life that's pure. Pure, like what kind of metal? Your table, like maybe steel. But actually, if you think of what steel is, it's actually a mixture. It's mostly iron and lots of carbon too. Let's think of something else that would be pure cement. Cement's also usually a mixture, right? You got rocks and sand and Portland and water. Aluminum. Okay, so if you have a chunk of aluminum, that would be a pure substance. So I'm going to put an X beside steel because it's not really a pure substance, it's a mixture, right? So let's talk about some pure things. Okay, so we could go through all the metals, right? Copper, tin, yeah, we could do that. What about something else around you that you could have pure? Okay, another metal, lead. Okay, wood. Wood's kind of strange because it's got different things in it. I guess you could have pure wood. Paper. What about how about sugar? Can you have pure sugar?
How do you make sugar?
Sugar? We get it from all sorts of different places. Sugar's in lots of stuff, right? Anything that basically ends in "ose" is a sugar. Sucrose, glucose, fructose, lactose, it's all in there. Plants make sugars, right? In photosynthesis, it reacts with water and light, and CO2 will make sugars and oxygen. What else? I'm trying to think of another one for you guys here. Okay, gold. Now, let's talk about jewelry gold, though. If you have a gold ring, is it pure gold? No, most rings are 14 karat or even 10 karat, which means it's a mixture. It's not pure. Right, so gold would have to be 24 karat to be pure. Right. Very expensive and very bendable. So most rings will be made out of 10 karat because they add other metals to make it stronger. So it doesn't actually, like if you had a bendy ring on your hand and you hit your hand on the desk or something, the ring's going to bend on your hand. That's no good, right? You want something a little stronger. So let's talk about which things are elements. Which of those are elements that we, okay, we'll put oxygen too. You can have pure oxygen, I guess. So which things are elements? Gold is an element. I'm going to put AU for gold. Copper, Cu. Aluminum, Al. And oxygen? Oh, and oxygen that we breathe is O2, so that's also an element. Now, water would be a compound. Why? What's it made of? Hydrogens and oxygens, right? H2O. What about sugar? You guys probably don't know what sugar is made of. It looks like this. This is one type of sugar. There's lots of different types. C6H12O6. There's a lot of carbons, hydrogens, and oxygens. So those are elements and those are compounds. And now if we go through, these three are atoms. This one is a molecule. And these are molecules and compounds. Again, we're just saying that anything that's a group of atoms together would be a molecule. And if the atoms are different, we'll call it a compound. Both things on the other side here, aluminum, chlorine, aluminum, copper, gold, and oxygen, they're also elements because you can find them on a periodic table. Yeah. To make sugar, I think I could. But I'm going to stop this now so that I don't have to keep recording.